limiting reagents. It is the reactant which is present in less quantity. It gets quickly consumed after some time, which limits the amount of product. Is called limiting reagent. Okay, so what is limiting reagent? Limiting reagent is a reactant which is available in less quantity and it gets consumed, then it results the small amount or it limits the quantity of the product formed. Okay, and the reactant other than limiting reagent is called because one is a small quantity means another quantity is available in excess, is it not? So that can be called excess reagent. Okay, so this is in excess quantity, that is apart from the limiting reagent. Usually the remaining amount of excess reagent can be calculated by subtracting the available amount of limiting reagent from the amount of excess reagent. So let us discuss about this limiting reagent and the excess reagent in stoichiometric calculations. Okay, so let us cite an example and based on that you will be able to understand this concept. Okay, take down this question. 50 kg of nitrogen gas and 10 kg of, remember when I put 50 kg instead of 50 kg I am writing 50.0. So what is the importance of this one? This is called significant figure. Do you understand? So how many significant figures are there? Three significant figures, right? Similarly, this one. So when they have particularly given significant in terms of significant figure, you are also expected to reproduce the answer. That is to give the answer in terms of that significant figure. Understand this? Right. Now, 10 kg of hydrogen as gas are mixed together to form or to produce ammonia gas. Now the question is calculate the ammonia formed. Calculate the ammonia formed. Identify identify the limiting reagent. Identify the limiting reagent in the production of NH3, in the production of NH3 in this situation. Now let us go step by step. Actually, we have four important steps. You have to note down all these four important steps. The first step is to write down the balanced reaction. Okay, take down. Step one. Can you suggest a balanced chemical reaction for this? First, write down the reaction. Tell me. N2 gas. You have to mention the physical state also. H2 gas. It undergoes an equilibrium. Yes, energetic gas. Now balance it. Can put 2 here and 3, right? So we have established the balanced reaction. Okay. Now let us calculate the moles aspect. We have to calculate the moles, right? And 1 mole, 3 mole, 2 mole. Okay. Now it is given as the moles of nitrogen, and what is the given weight here? 50 kg. So for 50 kg, the number of moles of nitrogen. So here they are given the weight. This is the experimental weight. We can put WE, right? And what is the weight they are given? Nitrogen is 50 kg. So put 50 kg. And this is mole. And what about this hydrogen? 10 kg. 10 kg, right? Okay. So with which we are supposed to find out the weight, the amount of ammonia. Okay. So let us work out the number of moles of the experimental reagents. And for 50 kg, what is the mole? Can you tell me? What is the formula you are supposed to use to calculate N weight by molecular weight? Okay. Now this is the clue, right? Now proceed. So what you are supposed to do? It is given in kg. You have to convert it into gram, right? So 50,000. Okay. So let us put 50 into 10 cubed. Similarly, 10.0 into 10 cubed, right? So this is the weight of gram. Okay. Now we have to find out the number of moles of nitrogen. So what is the formula? Ne is equal to weight divided by molecule. Okay. So what is that? Divided by 20. What is the 28? Why? For nitrogen, 28. Yeah, you can mention here also. Put molecular weight, and this is 28. What about this? 2. This one, 14 plus 3, 17. Okay. This is gram per minute, right? So what is the value? Use calculator. Yes, sir. So, 1785.71. So 17.86 into 10 power 2. Yes. Okay. So 17.86 into 10 power 2 mole. So this is the mole of nitrogen. Okay. Number of moles of nitrogen. Right. Now similarly work out for hydrogen. How much? 10.0 into 10 cube divided by 2. That is 5 into 10 power 3 mole. Okay. Got it? Got it. Now listen. So here we have nitrogen. How many moles? 17.86. Right? Now, can you work out the that is the moles? I mean the now we have to find out the limiting reagent. So we have worked out the number of moles. Okay. Now let us proceed further. Third step, take down. So we need to find out the limiting reagent, right? Okay. Now from this it's clear that 17.86 into 10 squared mole needs 5 into 10 cube mole of what? The carbohydrate. Okay. Now listen. So you have the nitrogen 17.86, right? So in this case, it should actually require 3 moles. Are you able to follow? According to the theoretical, what is that? Tell me, theoretical number of moles. 3 moles. Yes. Is it not for 3 moles? Okay. So let us find out for 17.86. Okay. How many moles are needed? Because we have got only this much amount. So write down to find LR what we are supposed to do. For 17.86 into 10 square, this is the available nitrogen. Got this point? Mole of nitrogen. Okay. And with which now we can have at the most 3 moles, right? So you can write down 3 moles of hydrogen. Okay. And if it is the case, what could be for 1 mole? So divided by 1 mole of hydrogen. Do you understand this? It means, see that you got the 1 mole and for which you require 3 mole. Okay. And what we are supposed to calculate for 17.86, how much is required? Do you understand this? Yes, sir. Okay. So it means what? That is, I have taken the simple ratio. What is that ratio? Number of moles of, what is that? Theoretical number of moles of, let me say, nitrogen and hydrogen, N2 and 3H2, right? So in this case, 1 mole, right? 1 mole, and that is nothing but the theoretical one. it requires 3 more. And what is the experimental one? Ne. How much is it? Is 17.86 into 10 squared, for which how many moles of hydrogen is required? Okay, so now we have to find out this. Do you understand this? Yes. So it means what we are supposed to do, you can simply make this as a ratio. Okay, so you can put x, this is equal to this much, is it not? According to mole ratio, these are equal. The mole ratios are constant. So 1 by 17.86 into 10 squared is equal to 3 by x. And that is why I put x. What is this x? The number of moles of hydrogen required for 17.86. That is Ne of hydrogen. Do you understand this point? So x is equal to, bring this x here. So it goes up. So 3 into how much? 17.86 into 10 squared. Now find out. So that means a 5.36, is it not, into 10 cube mole of hydrogen. Do you understand this? This is the number of moles of experimental number of moles of hydrogen required. Do you understand this? Okay, got it? Yes. But according to our previous calculation, how much is present here? We need 5.36. Okay, we need 5.36. But here we have got only 5. Got this point? Yes, sir. So now you know very well which is of less quantity than the hydrogen. So therefore here hydrogen is the limiting reagent. So you can declare like this. Okay. So since N experimental, okay, what is that? N experimental. What is that N experimental? 5.36 into 10 to the power 3. So that should be, that is according to the calculation. Okay. So theoretically speaking, theoretically speaking, N, you can put 5.36 into 10 power 3 mole hydrogen, but according to the experimental, that is actual amount of hydrogen, okay, is equal to how much we have calculated? We have only 5 into 10 cube, is it not? So 5 into 10 power 3 mole hydrogen only. So therefore, this Ne experimental is less than T of hydrogen. So you can declare hydrogen is the limiting reagent. Do you understand this point? Yes, sir. So we have now identified hydrogen as the limiting reagent. Take down. Now, what we are supposed to do, we have to find out the, the mole formed, ammonia formed. So that is step 4. So let us proceed with step 4. So here we have declared hydrogen as the limiting reagent because it has got the less quantity. Now, fourth one. So we need to find out ammonia, the quantity of amount of ammonia produced, right? Okay. Now let me rewrite nitrogen as gas plus 3 hydrogen as gas that undergo an equilibrium to give 2 moles of ammonia as gas. Okay. Right. Now, the 3 moles of hydrogen, here 3 moles. The experimental is not experimental, the theoretical. Moles is 3. And here you have got only 1 mole, right? So, 3 moles of hydrogen gives 2 moles of ammonia. Got this point? Okay. And what is our number of moles here? That is N experimental of hydrogen. How much? Yes. So 5 into 10 cube number of moles of hydrogen is there. And we need to find out ammonia. So divide this. Okay. So what is the ratio? 3 divided by 5 into 10 cube is equal to 2 by x. So find out x. So 3x is equal to 2 into 5 into 10 cube divided by 3. Work out. So make it as a 3.30 into 10 power 3 mole of ammonia is required. Got this point? Okay, so 3.3 mole of ammonia is obtained from how much? 5 moles of hydrogen, right? Now it is asked in weight. What we have found out is only mole. So you can once again convert this into weight. How to convert this into weight? We know already N is equal to W by M. So we are interested in W. So N into M. Now tell me N is 3.3 into 10 cube. And what is the molecular weight of ammonia? 17. Now tell me the value. How much? So it means 56.1 into 10 cube, right? This much amount of gram or kilogram? Gram. So this can be converted into kilogram because initially they are given in kilogram one. So 56.1 kg. Got it? Okay. So this is the way you have to calculate the final product and how much we can get. That is 56.1 kilogram of ammonia can be obtained from this experimental values. So the weight of ammonia obtained can be how much? 56.1 kg. So this is the way you have to report. And there are two questions here. Is it not? You please go through the question. What are asked here? Calculate the ammonia form, right? So that is how much? That is the first answer. How much? 56.1. And identify the LR, that is limiting reagent, and that is hydrogen. That is the second answer. That is hydrogen is the limiting reagent. So this is the way you have to do this limiting reagent. Any doubt? Please go through once again. If there is any doubt, you can ask me.